How often do you visualize artificial intelligence as a climber, persistently ascending a hill in search of the peak? This might seem like an odd comparison at first, but it serves as an excellent analogy for a strategy used in AI, known as hill climbing. Just as a hiker traverses a landscape, navigating valleys and ridges in pursuit of the highest peak, hill climbing and artificial intelligence operates similarly. It's an algorithmic strategy used in decision-making processes, where the goal is to maximize or minimize a certain value. Imagine the AI as our hiker. The landscape it navigates is a mathematical one, filled with potential solutions. Some paths lead to higher values, akin to higher peaks, and some to lower values, resembling valleys. The AI must determine the best path to take, just as a hiker decides which trail will lead to the summit. So, think of hill climbing in AI as a hiker who is determined to find the highest or lowest point, depending on the goal. But what exactly is this hill climbing in AI, and how does it work? Well, let's break it down. Hill climbing in artificial intelligence is a concept that may sound a bit daunting at first, but it's actually quite simple once you understand it. It's a heuristic search used for mathematical optimization problems. Now, you might be thinking, what in the world is a heuristic search? Well, in layman's terms, it's a technique designed for solving a problem more quickly when classic methods are too slow. In other words, it's a shortcut. Now, we've established that hill climbing is a heuristic search, but what does it do exactly? In AI, it's used to find the best possible solution to a problem. Imagine you're on a hike. Your goal is to reach the highest point, the peak of the hill. So, you'd naturally start walking towards the direction where the ground is getting higher, right? That's exactly how hill climbing works in AI. It's a local search algorithm, which means it starts with a solution and then tweaks it little by little, evaluating each tweak to see whether it's an improvement. If it is, that's the new solution. If it's not, it's discarded. The algorithm keeps doing this, always moving towards the direction of increasing elevation, or in AI terms, increasing value or quality, until it can't find any more improvements. So when is hill climbing used? Well, anytime you need to optimize. Maybe you're trying to find the shortest route from point A to point B, or you're trying to schedule tasks in the most efficient way possible. Whatever the case, hill climbing helps find the peak solution, the optimal answer. Now remember, hill climbing is a heuristic. It's not perfect. It might get stuck at a local maximum, thinking it's the highest point when there's actually a higher one elsewhere. But that's a topic for another time. In essence, hill climbing in artificial intelligence is all about finding the best solution by continuously improving upon the current solution. So, what are the main points to remember about hill climbing in AI? Firstly, let's not forget that hill climbing is a heuristic search algorithm used for mathematical optimization. This means it's a method used to solve problems where the best possible outcome within a given set of constraints needs to be found. It's like a mountain climber who continually moves uphill, aiming for the highest peak. The algorithm works similarly, always moving in the direction of increasing elevation or value to find the optimal solution. Another important point to remember is that hill climbing is a local search method. This means it starts with an initial solution and iteratively improves it by making local changes, until no further improvement can be found. It's all about finding the best solution by continuously improving the current one. Like a miner who starts digging where the gold seems plentiful and keeps on digging deeper in that area until no more gold can be found. However, hill climbing is not without its pitfalls. The algorithm can get stuck in local maxima, which are peak points that are not the highest peak, but higher than the surrounding points. Imagine our mountain climber again, who has reached a high point but is surrounded by valleys. She can't see any higher points from where she's standing, so she might think she's reached the highest peak, even though there might be a higher one just beyond the next valley. Despite its limitations, hill climbing is widely used in artificial intelligence for its simplicity and efficiency. It's a great tool for problems where the solution space is large and complex, and where exhaustive search is not feasible. So whether it's about finding the shortest path in a graph, solving a puzzle, or optimizing a mathematical function, hill climbing can be a useful tool in the AI toolbox. Remember, in the world of AI, hill climbing is not about physical prowess, but about the relentless pursuit of the optimal solution.